In section 10.1, we're going to learn another way to solve quadratic equations. Now, we've solved quadratic equations before. X squared minus 64 equals 0 is an example of such a quadratic equation. But there's been a temptation. In fact, I think Preston was like saying, well, why don't you just move the 64 to the other side? And you can do that. X squared equals 64. But then what would you do? What would you do from here? Take the square root. Sure, nothing wrong with that. Square root of x squared, square root of 64, taking the square root on both sides. What does x equal? 8. Now, old school would say I do it this way. I factor this. So help me out. How does x squared minus 64 factor? Yeah, negative 8 and positive 8. So what are my two answers here? Can you read them off? Good. X equals 8 and negative 8. Except we run into a little bit of a problem with the way we did it just a moment ago. We only got one solution. So here's the fix for that. Back in section 9.1, you might remember me doing this. I put a little plus and minus out here. And now that plus and minus gives me both solutions. I've got the plus 8 and the negative 8. So that's what we're going to do in section 10.1 is we're going to use what's called the square root property. So square root property. And the square root property simply says this. If x squared equals a, then x equals plus or minus the square root of a. So that's the nuts and bolts of it. Now the book might not write it like this. The book might write it out in both cases. X equals the positive square root of a or x equals the negative square root of a. These and these in my mind are equivalent. Either way you write it is up to you. But this is the square root property, and it can get a lot of work done for us. Using it, we can solve equations that we couldn't when we were just factoring. Still see a few of you writing, so I'll give you another second on that before we start problem 16. So problem 16, oops, it's a w squared. Right, sorry. W squared minus 47 equals 0. Now, unfortunately, you can't factor this one like you could the previous one. 64 was a nice perfect square. 47 isn't. So, bummer. But what you can do is move this to the other side. So what would that look like? Well, what happens when a term changes side? What else changes? The sign. So it's w squared equals 47. And just take the square root. W is plus or minus the square root of 47. And that's as far as you can go. 47 is not a perfect square. It's not even a composite number. It's a prime number. Yes? So if it's not a perfect square, then just leave it as plus or minus whatever square root. Yes. Now there is a little bit more you can do on some numbers. I'm not necessarily going to make you do that, but I'll show it to you. And it's kind of a buildup of things to come for you, but not necessarily this semester. Are we good in problem 16? Chelsea? Okay. Problem 20, same thing. Move the 24 to the right-hand side. What could u equal? I'm waiting for somebody to tell me what u could equal, please. Yeah, plus or minus the square root of 24. Great, just take the square root on both sides. Now, I haven't actually shown that, but I mean, you can. square root here, squeezing the plus or minus. Square root of the u squared gives me the u. This is okay as far as it goes. If you looked up your answer in the back of the book, or maybe if you're doing this on WebAssign, if you looked it up there, then it's going to look a little different. As far as the test is concerned, I'll be happy with this. If you want to pick up an extra credit point, or two, maybe at least two, then let's look at 24. On the left-hand side board, I've listed to you all the perfect squares up to 20. Which one of those perfect squares evenly divides 24? What number from that list? Well, hang on. This is your list of perfect squares. 1, 4, 9, 16, 25, etc. Which one off this list evenly divides 24? Yeah. 2 squared is 4, right? So 4 evenly goes into that number. So 4 goes into 24 6 times, right? 4 times 6 is 24. But do you see where I'm getting the 4 from? It's a perfect square. You can take the square root of 4 in your head. What's the square root of 4? 2. So plus or minus 2 square roots of 6. That's what you're going to see your answer looking like in WebAssign or in the back of the book. It's plus or minus 2 square roots of 6. This is fine for this class. This is extra credit for this class. Any other thoughts on problem 20 here? Let's do problem number 22. Yes, it was. So 5x squared minus 49 equals 0. Ying, what do you think I should do first here? Sure. We'll move 49 to the right-hand side. I'll actually show it in this one. I'm adding 49 to both sides, so I get 5 squared equals 49. Good. What could I or should I do next? Anyone? Yeah, let's divide by 5 on both sides. So I get x squared equals 49 over 5. Yay. Okay. Then what? Square root on both sides. And on the right-hand side, we'll take plus or minus the square root. So it's going to be x as plus or minus the square root of 49 over 5. Let's do a little bit of work with this. Because this is a division, you can split it up. You can't split up addition or subtraction, but you can split up division or multiplication. I'll write that as plus or minus the square root of 49 over 5. Does that help me out at all? Can I simplify this anymore? Well, there's nothing to do in the denominator just yet, but I can take the square root of 49 as 7, and that'd be a good place for this class to leave it. You can go a little bit farther. So again, this is for the extra credit, so that your answers match the book or WebAssign. If you multiply by the square root of 5 over the square root of 5, in the denominator, 5 times 5 gives me the square root of 25. In the numerator, not much happens. But there is one last thing I can do in the denominator. And what's that? Square root of 25 is 5. So a hush falls over the crowd. I don't expect this last part here. I think the reason that they did this goes back to pre-calculator days. So the reason there was because it's easier to divide by a rational number as opposed to an irrational number. I think that's part of it. Not sure. But mathematicians in general don't leave these square roots in the denominator. For this class, that would be fine. And this is extra credit. Let's keep working with the square root property. We're going to do 2 more problems using the square root property. I'm going to do the first one, and I'm going to have you do the next one. So try and pick this up. X minus 1 squared equals 4. So, okay. What do I do next? Or what do I do first, I should say? Can I apply the square root property here? Why not? Let's take the square root on both sides. Remember, there's something I'm missing on the right-hand side. What am I missing? Plus or minus. You need that plus or minus there. How's this going to simplify? What's my next line in this series of equations going to be? Yeah, thank you. X minus 1 is plus or minus 2. Now here's where you have to slow things down just a little bit. What you cannot do is move the 1 to the other side and say, oh, plus or minus 3. Done. Let's understand what this really means and then solve it correctly. There's 2 possibilities represented by what I have here. It's x minus 1 equals 2, or what's the other possibility? X minus 1 equals negative 2. Now in both cases, to solve, you're going to add 1 to both sides. On the one hand, you get 3, but what do you get on the other one? Thank you, negative 1. So like I said just a minute ago, you can't just move this blindly over to the right-hand side and get plus or minus 3. That doesn't work. Negative 3 would not work as a solution. Positive 3 works. 3 minus 1 is 2. Squared is 4. Negative 1 minus 1 is negative 2. Negative 2 squared is still positive 4. So both of these check. Negative 3 wouldn't work. If you put in negative 3 minus 1, you get negative 4. Squared is 16. Is there anything here that I can help out with that you're a little uncertain because you're about to be given a problem yourself to try? We good on problem 32? All right, your turn. Try problem number 34. Pretty much the same thing, different numbers, but pretty much the same thing. That's an S, yes. Yeah, sorry. Sorry, I'll come by to you guys next time. Like the last one, we'll start out by taking the square root on both sides. On the left-hand side, you get s minus 7. On the right-hand side, it's plus or minus 3. You need to break that up into two cases. So the positive case is s minus 7 is positive 3. And the negative case is likewise a negative 3. We'll add 7 to both sides. So s equals 10, or s equals 4. And those are your two solutions. Now, what if you were anxious to check those? If you're looking at that going, nah, I don't know, I don't trust those. How could you check it? Plug it in. 10 minus 7 is 3. 3 squared is 9. 4 minus 7 is negative 3. Squared, again, is 9. So they both check. Now, these last couple problems, we were fortunate to have this thing already done for us, that there was a nice perfect square on the left-hand side. You're not always going to be so lucky, so sometimes we're going to have to kind of create that for ourselves. We're going to have to do a process called completing the square. And that's what we're going to finish up with, is completing the square. So, completing the square. Okay, let's start out this way. Let me kind of demonstrate what we're going to need to think about and what these problems are really all about. Suppose I had x plus 5 squared, and they ask you to figure out what that is. So, I guess one way to do it is to multiply x plus 5 by itself and get x squared plus 5x plus 5x again plus 25. Hopefully, if you did that, you would take the time to add up the like terms in the middle. X squared plus 10x plus 25. All right, so what we're going to face in this section is this. You're going to be given the first two terms of something like this, and based on these first two terms, we're going to have to figure out the 25 and that this factors like this. That's going to be our challenge. So how are we going to start out with a 10 and figure out a 25? Well, where did the 25 come from? 5 times 5. Or in other words, 5 squared. Same thing. All right? What's the relationship between the 10 and the 5 that we need to square? Well, that 5 was really, or that 10 is really 5 plus 5. If you needed to work backwards from that 10 to get these 5s, you can just divide by 2. Divide this by 2, you get 5. 5 squared is 25. So that's kind of pushing you in the right direction of how we're going to do this. Let me write it down for you in general terms, and then we're going to do a bunch of practice problems. This is a B. It's not a 6. Just FYI. I know. I've gotten grief about it some other class. But the idea here is that we're going to start by multiplying this middle term by 1/2, like dividing by 2. So to complete the square, multiply 1/2 times b. So in this above example, it would be like 1/2 times 10. That 1/2 times 10 is going to give you 5. Then you're going to square this result. Square the result from the first part. Or in other words, 1/2 b squared. These two numbers are going to help you fill in what I have up here. That number is going to complete the square here. This one is going to help us factor it. It might look a little messy and abstract at this point. We're going to start putting some numbers to it, some actual examples, just like the problems that I would give you in an exam, so you can really get a handle on what's going on here. I don't think it's going to be so bad. We'll start with problem number 40. And I'll write it not the way the book writes it, but the way that I'll write it on an exam. So what you're going to be given is something like this. Y squared minus 18y plus something. Now if we figure out the right something to put here, then this will factor as the square of some binomial. Something minus something, something plus something squared. So let's see about doing that. Well, I've got a little set of advice or set of instructions here to follow. Let's start by multiplying 1/2 times this number out in front, times -18. So 1/2 times -18 gives me -9. That's the first step. The second step is to square the result from the first step. So -9 squared. What's -9 squared? 81. Yes. Yep, goes right here. So if I put an 81 here, then this is now a perfect square trinomial. In fact, let me do it down here. If I gave you y squared minus 18y plus 81 and said factor that, you'd look at that and say, okay, that's a trinomial, a y and a y. Since this is positive, I get a positive product if I either have two negatives or two positives. In this case, it has to be two negatives. What two numbers multiply to 81 and add to 18? 9 and 9. I've already got that. So I already got the sign, so just 9 and 9. But y minus 9 times y minus 9 can also be written as y minus 9 squared. So that's what's going on here. You figured out the perfect number so that your trinomial was the square of a binomial. Like that. You don't have to go through all this stuff. Just do this. Figure out what number goes here, and then this number helps you out here. Anything else on problem number 40? You know, for simpler problems like this, you probably do it in your head, and I'm okay. It's always nice for me to see some of your work, but I could certainly understand that people could do a problem like that in their heads. There will be a couple that probably want to write down something. All right, but on those, when you have nice even numbers, I'm sure you can get away without it. Let me give you several more examples. A couple more of the friendly variety, then we'll make them a little bit more challenging. A squared plus 12a plus blank is something squared. Again, let's do the same two steps to complete the square that we just did. Okay, so half of 12 is 6. 6 squared is 36. So the 36 goes here. What goes here? A plus 6. Thank you. So this number actually helps you out here. You're going to see it in your factorization. A plus 6. Perfect. You want another easy one, or can I start moving into hard ones? You want one more easy one? Hard? All right. We'll do a couple hard ones then. Problem number 42. B squared plus 11b plus blank is something squared. Why is this one going to be harder? Yeah, this isn't a nice even number. It's okay. Now, when I started this, I carefully said that you're going to multiply this number by 1/2. 1/2 times 11 is 11 over 2. And from there, what should you do? I've got 11 over 2. What next? What was the second step? Square it. So 11 over 2 squared. Let's do it without our calculators. Start with the denominator. 2 squared. 4. 11 squared. 121. You can get that from your calculator or off the left-hand side board. But I just squared both of the terms in the numerator and denominator. Chelsea, where does this 121 over 4 go? You could put it as a decimal. I'd rather see it as a fraction. It's not wrong as a decimal. What's that? So where does it go then? All right, so in here with the blank. Good. So 121, 121 over 4. I need something over here, though. What goes over here? Anyone? B plus 11 over 2. Okay. And that's it. That's it. So it's the same steps as last time. You multiply the middle number by 1/2 and then square the result. Okay. Problem number 44. Again, a little bit on the challenging side. X squared plus 2/5 x plus something is something squared. Elizabeth, how should I start? All right, 2/5 times 1/2. I'd make a suggestion here for you. Don't multiply this together and get 2/10. What should you do? Cancel, absolutely. 2 and the 2 cancel, so I'm left with 1/5. All right, thanks, Elizabeth. What next? What do I do after that? 1/5 squared is 1/5 times 1/5. Don't say 1/10. What is it? 1/25. Heather C. Can you help me use those things to finish filling in this? What am I going to get? What goes here and here? Madison. What number That's on front. How do I finish this? Where do these numbers go? Good. The 1/25 goes here. Perfect. The 1/5 is going to help us out here. It's going to be x plus 1/5. Actually, if this turned out negative, it would be x minus 1/5. It's just whatever comes out here is going to be here. And then you got to put your variable there. Now, why would people do stuff like this? A lot of the answer lies in some math that you are not going to see this semester. But there is an example that I could show you of where you could use it now. I mean, why somebody would do it now. And that is to solve quadratic equations that we can't yet solve in other ways. An example of something like that would be problem number 48. X squared minus 6x minus 4 equals 0. Unfortunately, that problem is not x squared minus 6x plus 5 or something like that, because that kind of stuff would factor. This doesn't factor. So we can't use the square root property because we don't have x by itself or some expression by itself that we can take the square root of yet. But we can work there. If I added 4 to both sides, I get something like this. Then what? Let's complete the square right here. So how do I do that? How do I make the left-hand side a perfect square binomial? We just did this for like 4 problems in a row. I take half of what number? Half of negative 6 is negative 3. Negative 3 squared is 9. So what if I added 9 to both sides? So 9 is our magic number that completes a square. If I add 9 to both sides, on the right-hand side I get 13. But what do I get on the left-hand side? I get this. But is there a different way I can write this? Well done. X minus 3 squared. Just put us that much closer to being done. Now that I've got it rewritten like this, what can I do to finish solving here? Can anyone suggest something? You're on the right track. I'll take the square root of both sides. Now remember, on the right-hand side, it's not enough just to take the square root. You need to take plus or minus the square root. So I get x minus 3 equals plus or minus the square root of 13. If I add 3 to both sides, I get x equals 3 plus or minus the square root of 13. And that's my answer. There's nothing wrong with leaving it like this. That works out fine. Or you could write it as x equals 3 plus the square root of 13. And x is negative 3, or excuse me, positive 3 minus the square root of 13. So these two solutions. Or I could write it neatly and concisely like that. Either one works for me. So that's a different way to solve quadratic equations. I'm not a huge fan of this. It's probably why you're only going to see one example like this. We're going to learn something a little bit better in the next section, a little bit more general, called the quadratic equation, quadratic formula, I should say. So that'll be a lot of fun, but you're going to have to wait until Wednesday for that. Until then, For homework, try 15 through 21, 31, 37, and 71. Now to complete the squares, just like we did just a moment ago, complete the squares is not something I'm going to test you on in terms of solving quadratic equations. So you won't have something like 48, but you will get stuff like this. These are the kind of completing the square problems that I want you to be able to solve. But if you want to practice some of the complete the squares so that if I put an extra credit problem on the test like that, you can solve it, those numbers would be 39 through 45, and I should probably just write 39 through 53, really. Will be your completing the squares homework. So, good luck, and see ya.